for a video lesson for section 2.2. And so we're going to start talking a little bit about matrices. So a matrix is just like a table of numbers or of anything really. And the size of the matrix, which is also sometimes referred to as the order of the matrix, is described by the number of rows by the number of columns. So the rows are horizontal, the columns are vertical. And you see on our example here, it says A equals. This is just an example of a matrix, and the little subscript, like when it says A with a subscript 1, 1, that means this is the entry in row 1, column 1. And when it says A1, 2, that is just referring to the entry in row 1, column 2. Okay, so that's what that means. Okay, so for problem number 1, we have matrix A, and the size of that matrix would be a 2 by 4. Okay, and element A2, 3, row 2, column 3, in this case is -4. And A1, 2, that'd be row 1, column 2, so that would be 3. And then A3, 2, that would be row 3, column 2, so in this case it's not applicable since there is no third row. And then row 2, column 4, in this case that would be 8. And for number 2, we have matrix B, and the size of that matrix is a 3 by 2, 3 rows, 2 columns. And then B2, 3, row 2, column 3, does not apply because there is no column 3. B1, 2, row 1, column 2, in this case would be 0. And B3, 2, row 3, column 2, in this case that would be -1. And B2, 1, that would be row 2, column 1, in this case that would be 4. And number 3, matrix C, is a 1 by 3, 1 row, 3 columns. So C1, 2, row 1, column 2, in this case that's pi. And then C2, 1, row 2, column 1, that doesn't apply because there is no row 2, there's only one row. C1, 4, row 1, column 4, also not applicable since there's no column 4. And C1, 3, in this case, row 1, column 3, that would be 97. Okay, so that just gives you a little bit of a feel for what a matrix is. And now we're going to look at using matrices to solve equations. So, systems of equations, really. So this is just another method to solve a system of equations. So like on number 4, we have a system of 2 equations with 2 variables. And the first step to using a matrix to solve that system would be to write down the augmented matrix. So to do that, it's just going to be a matrix with the numbers from the system in the matrix. So in this case, we have 3x plus y equals 5, and we know that y is the same thing as 1y. And the second equation we have is 2x minus y, and we know that that y is the same thing as 1y also. And then so when we write down the augmented matrix, it's going to be, the first column is going to be 3, 2, the second column is going to be 1, -1. And then where the equal sign is, we're going to have a vertical line, and then we're going to have a 5 and a 5 in the last column. And that's going to be my augmented matrix. Okay, so we wrote the augmented matrix, and then that's all we have to do for that. And then for number 5, we're just going to do the exact same thing. And since like On the second equation, there is no y, so we can insert plus 0y here. And we know that's 1z, 1x, 1y. Alright, so this will be our augmented matrix. So the first column would be -4, 1, 3. The second column would be 2, 0, and 1. The third column would be 1, 3, -4. And then the last column would be 1, -5, 10. Alright, and then number 6, we want to write down the system represented by the matrix, and in this case they've instructed us to use x1 and x2 for our variables. So that would just be 1x1 minus 3x2 equals 5, and 0x1 plus 2x2 equals 7. And we can simplify that a little bit by just saying x1 minus 3x2 equals 5, and then 2x2 equals 7. And so that would be the system that's represented by that matrix. Alright, so then also in order to solve systems with matrices, we need to know how to do row operations. So there's 4 row operations that we're going to be doing. The first one is row swap, which is pretty simple, explanatory. You're just going to swap 2 rows. And then row plus, meaning add 2 rows. So if you see R1 plus R2, and then the arrow, so that becomes the new row 2. A row times, that would be like just multiplying a row times a number. And then times row plus is a really common one that we use a lot, which means we're going to multiply a row by a number and then add it to another row. So this means -2 times row 3 plus row 2 becomes the new row 2. Alright, so let's just do some examples of how these will work. So for number 7, we have this matrix, and we want to swap row 1 and row 2. So then the first column would be 1, 2. The second column would be -1, -3. And then the last column would be 6, 8. And then number 8, so you may notice that the starting matrix for number 8 is the same matrix that we got for the answer on number 7. And number 8 says we're going to do -2 times row 1 plus row 2 to get the new row 2. Alright, so that would be, so we're going to go to row 2, we're going to do -2 times 1, and then -2 times -1, and then -2 times 6. So the first row is going to actually stay the same in this case. And the second row is going to be 0. So that'd be -3 plus 2, so that's -1. And then 8 minus 12 is -4. Okay, and then number 9, we're going to take that matrix, we're just going to multiply row 2 times -1. So it's just going to be times -1 times -1 times -1. So again, the first row stays the same. Second row is going to be 0, 1, 4. And then the last step is number 10. You're just going to take row 2 and add that to row 1 to get the new row 1. So here you just do plus 0, plus 1, plus 4. So now the the second row stays the same this time. The first row is going to be 1, 0, 10, and the second row is 0, 1, 4. Alright, so basically what we just did there was we solved the system. And if this was if we were solving this system, our answer to this system would be 10, 4. Because this column would represent x, this column would represent y, this is the equal sign. So x equals 10 and y equals 4 is what it's telling you. Or in other words, your solution is 10, 4. Alright, and we're going to talk more about that on the next page here. So that's the Gauss-Jordan elimination method. Okay, so we've basically already gone over all of the steps individually of this method. Okay, so the goal with the Gauss-Jordan method is to make your matrix where it has 1s on the diagonal and then 0s everywhere else. So as you can see at these two examples right here. Alright, so let's actually do a whole example of that method. So the first step is write down the augmented matrix. So in this case, the first column would be 2, 1. The second column would be -5, -3. And the last column is -1, -3. So we always work one column at a time. So, and then we always start with the 1 that we're trying to do in that column. Okay, so we basically want our answer to look like this. So that means that we want to start by making a 1 to land in the first row, first column. So in this case, the easiest way to do that would be to just swap the two rows. And that way we would have a 1 in the first row, first column. So we're just going to swap row 1 with row 2. So now my first column is going to be 1, 2. My second column is going to be -3, -5. And my last column is going to be -3, -1. Okay. So I'm still working on the first column. So the next thing that I need to do on that first column is I need to have a 0 in the first column, second row. So instead of where this 2 is right now, I need to actually have a 0 there. So to do that, I'm going to use the opposite of that 2, which would be -2. I'm going to multiply that by the row that I just created a 1 in, which is row 1. And I'm going to add that to row 2, and that's going to become the new row 2. So what I'm going to do is I'm going to do -2 times 1 -2 times -3 and -2 whoops, oh, okay, yeah, times -3. Okay, so once I do that, my first row is still going to be the same. Now my second row is going to be 0, and let's see, -5 plus 6, so that's going to be 1, and then -1 plus 6 is going to be 5. Okay, so I'm done with my first column, so now I'm working on my second column. So I always start with the 1. So in this case, I would want to have a 1 right here, and I already do have a 1 right there, so I don't need to do anything for that. The next thing I need to do then is I need to have a 0 here. So it's going to be similar to what I just did on the last step. So the opposite of -3 would be +3. I'm going to multiply that by the row that has a 1 in it for that column, which is row 2, and I'm going to add that to row 1, and that's going to become the new row 1. So this is going to be plus 3 times 0 plus 3 times 1 and plus 3 times 5. Okay, so my first row, it's going to be 1, 0. Negative 3 plus 15 would be 12. And the second row stays the same, 0, 1, 5. Okay, and now I'm basically done. So my solution is 12, 5. Okay. Okay, so now we're going to look at an application problem. So similar to some of the application problems we did on the last section, but I'm going to try to actually solve this one with Gauss-Jordan method just to show you how that would look. Alright, so your boss asks you to buy sodas for an office party. She wants you to get a total of 15 2-liter sodas, some Dr. Pepper, some Coke, and some Diet Coke. You decide to get equal amounts of Coke and Dr. Pepper. 2-liter bottles of Coke and Diet Coke cost $1 per bottle, and Dr. Pepper is on sale for 80 cents per bottle. If you spend a total of $13.80 on sodas, how many of each type did you buy? Okay, so first of all, we need to define the variables. So let's say X equals the number of Dr. Peppers Y equals number of Cokes, and Z equals number of Diet Cokes. Okay, so then we're going to write down our system of equations. Alright, so we want a total of 15. So that tells me that X plus Y plus Z equals 15. Then it says you decide to get equal amounts of Coke and Dr. Pepper. So that just tells me that X is equal to Y. Okay, but if I want to have that lined up like the rest of my equations, I would subtract Y from both sides, which would give me X minus Y is equal to 0. Alright, and then finally we would look at the cost. Okay, so Coke and Diet Coke is $1 a bottle. Dr. Pepper's on sale for 80 cents. So the total was $13.80. So 0.8x, because the x was the Dr. Pepper, plus 1y plus 1z is equal to 1380. Okay, so if I'm going to use Gauss-Jordan to solve this, I'm going to write down the matrix. So my first column is going to be 1, 1, and then 0.8. And my second column is going to be 1, negative 1, 1. My third column is going to be 1, 0, 1. And my last column is going to be 15, 0, and 13.8. Okay, so the first thing I would need to do is I would need to make sure that I have a 1 right here, which I do. So that means the next thing I need to do is make sure that I have a 0 right here. So for that, I'm just going to use the opposite of positive 1, which is negative 1. Multiply that by the row that I have to have a 1 in, which is row 1 for this column, and then add that to the row that I'm trying to change, which is row 2, and that becomes my new row 2. So I'm changing row 2, so this is going to be minus 1 times 1, minus 1 times 1, minus 1 times 1, and minus 1 times 15. Okay. So now my second row is 0, negative 2, negative 1, and negative 15. Alright, and then I'm going to do the same thing on the third row, because now I need for this positive 0.8, I need that to be a 0 as well. So the opposite of positive 0.8 would be negative 0.8. Now I multiply that times the row that has the 1 in it for that column, which is row 1, and then I add that to the row that I'm trying to change, which in this case is row 3, and that gives me my new row 3. Okay, so this is going to be minus 0.8 times 1, minus 0.8 times 1, minus 0.8 times 1, and minus 0.8 times 15. Okay, so that's going to be 0. 1 minus 0.8 would be positive 0.2. So that's also 0.2. And let's see, let me just get out my calculator for the last one. So I've got, let's see, 13.8 minus 0.8 times 15. So that's giving me 1.8. Okay, and then my first row didn't need to change that time, so I'll just copy that down. Okay, so my first column is finished. So now I'm going to move on to my second column. So now what I have to do, so I start with where I need the 1 to be. So I need have a 1 instead of negative 2. So to do that, I need to multiply by the reciprocal of negative 2, which would be negative 1/2. So I'm going to do negative 1/2 times row 2 gives me the new row 2. Okay, so I'm just multiplying all of this row 2 times negative 1/2. Okay. So now that's going to be 0, 1, 1/2, and 15 over 2. Alright, and I'll just bring down the other rows. Okay, so next I need to have a 0 in place of this 1 in the second column. So to do that, I'm going to take the opposite of positive 1, which is negative 1, multiply that by the row that's supposed to have a 1 in it, which in this case is row 2, add that to the row that I'm trying to change, which is row 1, and that's going to become the new row 1. So this would be minus 1 times 0 minus 1 times 1 minus 1 times 1/2 and minus 1 times 15 over 2. Oops. Okay. So row 1 now is going to be 1, 0, 1/2, and then 15 minus 15 halves is going to be 15 halves. Alright, and then I'm going to do the same thing for the third row. So I need this 0.2, I need that to turn into a 0. Okay, so I'm going to do the opposite of positive 0.2, which will be negative 0.2. Multiply that by row 2 and add it to row 3 to get the new row 3. So this would be minus 0.2 times 0 minus 0.2 times 1 minus 0.2 times 1/2 minus 0.2 times 15 over 2. Okay, so that's going to be 0, and that's going to be 0, and let's see, this is going to be 0.1, and let's see, 15 over 2 would be the same thing as 7.5, so I've got 1.8 minus 0.2 times 7.5 equals 0.3. 0.3. Okay, now the middle row is still the same. Okay, so the second column is now completed. Okay, so now I need to go to the third column, and I'm starting with where the 1 is supposed to be. So I'm supposed to have a 1 right here instead of 0.1. Okay, so what do I need to multiply with 0.1 to get 1? Well, the answer to that would be 10. So I need to multiply 10 times row 3 to get the new row 3. So I'm just going to go times 10 times 10 times 10 times 10. Okay, so that's going to give me 0, 0, 1, 3. And I'll just bring the other rows down. Okay, now I need the 1/2 to turn into a 0. So to do that, I need to do negative 1/2 times row 3 plus row 1 gives me the new row 1. So it's going to be minus 1/2 times 0 minus 1/2 times 0 minus 1/2 times 1 minus 1/2 times 3. Alright, so that would be 1, 0, 0, and then this would be, let's see, 15 halves minus 3 halves would be 12 halves, which would be 6. Alright, and then I'm going to do the exact same thing for row 2. So I'm going to do negative 1/2 times row 3 plus row 2 to get the new row 2. So minus 1/2 times 0, minus 1/2 times 0, minus 1/2 times 1, and minus 1/2 times 3. So that's going to be 0, 1, 0, 6. And then the bottom row stayed the same. 0, 0, 1, 3. Okay, so now we are done. So if we go back and we look at where we defined our variables, X was Dr. Pepper, Y was Coke, Z was Diet Coke. Alright, so let's go ahead and write our answer as a complete sentence. So, you bought 6 Dr. Peppers, 6 Cokes, and 3 Diet Cokes. Alright. Now, I know that seems like a lot more work than was really necessary, but the good news is that if you want to use the methods that we used in the last section to solve this problem, you're more than welcome to do that. So just because it says you have to use this method, well, who's gonna know, really, right? Alright, so anyway, thanks for watching, and I welcome any comments, questions you might have. Alright, thanks.